Okay, today's video is about solving absolute value equations. This video will work the same for Intermediate Algebra 2 and Regular Algebra 2. However, I am using the notes from the Regular Algebra 2 class. So students in the Intermediate class, you'll notice that this does not look exactly the same, but it will teach you the same concepts and you'll be able to learn them well enough to do your homework. All right, so let's get started. First off, we're going to skip this warm-up question and just jump right into the content. All right, what we need to know, an absolute value can be defined as the distance on a number line from any particular value to 0. This means that an absolute value of a number cannot equal a negative. Okay, so let's think about this for a second. Find something in the room that you're in. Go stand next to it. Now try to stand -1 feet away. How do you stand -feet away? You can't jump inside it. If you back up so you're a foot away, it doesn't matter whether you're left, right, above it, below it, you're still a foot away, not a -foot away, okay? Because absolute value is distance, distance cannot be negative. Absolute value cannot be negative. So the absolute value of 4 is 4. The absolute value of -12 is 12. Absolute value of 0, of course, is 0. Now, pay attention to this last one. This says the absolute value of 7 and then make it negative. So absolute value of 7 is 7. Now make that negative. So this is -7. Pay attention to whether the negative sign is inside or outside of the absolute value bars. All right, scrolling down. We're going to work with equations which contain absolute values. In each of these problems, you must set up 2 equations because there are 2 values for x that make the equation true. What does this mean? Let's do the first one and let's show you. All right, x, absolute value of x equals 11. So I want, if I'm graphing this on a number line, I want from 0, everywhere that is 11 units away from 0. Well, positive 11 is 11 units away, but -11 is also 11 units away. So the absolute value of this is going to be -11 and 11. Those are my answers, all right? So visually, that's there. So my answer is going to be x equals 11, x equals -11. All right, same thing with 2, the second one here. Absolute value of x equals 2, which means that x equals +2, x equals -2. Let's do the graph again just so we can see. And for this one, we're actually going to draw all of our numbers and we're going to count. 1, 2, 3, 1, 2, and 3. Okay, starting at 0, let's count. What's 2 away from 0? 1, 2. Oh, hey, that's +2. Let's go the other direction. 1, 2. -2 is also 2 places away. It has a distance of 2 units away from 0. You seeing how this works? Okay, looking at the next one. The absolute value of x equals -5. Wait a minute. Remember what I said? It can't be a negative number. Can I have a negative distance? Can I start at 0 and go -5 units away from it? No, it's not possible. So watch for these. They're going to sneak up. So this one has no solution. And if you want to get snippy with it and add an exclamation point, that's absolutely fine. Okay, what do I do with this here? Absolute value of 2x equals 24. How do I solve that? All right, so first, the strategy for this is first we're going to split it into 2 equations. We know that the absolute value of 2x equals 24, so then we can say that 2x equals 24. We can also say that 2x equals -24. All right, this is the same thing that we did over here on our first 2. You saw how we split it? We said 11, -11, 2, -2. We're doing the same thing here. We're saying 24 and -24. The only difference with this is I've got extra stuff inside the absolute value bars. So I can't just say I have a solution right now. Once I've got it split, now I have to actually solve it. So I don't care what 2x is. I want to know what x is. So I divide both sides by 2. So x equals 12. Go over here to my second one. Divide both sides by 2. So x equals negative 12. All right, let's scroll down. And we have a few more complicated ones here. So let's look at this first one, and then we'll look at the third one. All right. It's supposed to be a star, not a B. Smart Notebook's not keeping up with me today. All right, so let's split it apart first. All right, x minus 5 equals 3. X minus 5 equals negative 3. Then solve for x. I'm going to add 5 to both sides. X equals 8. Add 5 to both sides here. X equals 2. All right. Now let's do this last one because it's a little more complicated just because of that 2x. So first, once again, split it apart. Don't try to do anything until you split it apart, all right? 2x plus 5 equals 9. 2x plus 5 equals negative 9. All right, get rid of our 5's first. It's being added, so we're going to subtract it. Minus 5 gives me 2x equals 4. Divide both sides by 2. So x equals 2. Let's go back to our other equation. Subtract 5 from both sides. So 2x equals negative 14. Once again, divide both sides by 2. So x equals negative 7. All right. So those are the basic ones. What we need to go over now is what happens if I've got more on the side of the equal sign with the absolute value. What if it's not by itself? All right. So in some problems, we must isolate the absolute value portion first before we can set up the two equations and solve. So you got to get this absolute value part by itself before you split it. Do not split it before you've isolated it. All right, absolute value by itself on one side of the equal sign first, then split it. All right, one word of caution, absolute value bars do not work the same way that parentheses do. What this means is never ever under any circumstances should you distribute into an absolute value. Don't do it. So when you see one like this, these absolute value bars, they're walls. All right, they're big, giant, huge brick walls. You do not distribute through them. No, never. Okay, so let's work a couple of these examples. All right, so the first one, x plus 4 minus 3 equals 1. I want the absolute value by itself, so I gotta get rid of this 3. It's being subtracted, so let's add it. So that gives me plus 3, there we go. That gives me the absolute value of x plus 4 equals 4. Now I split it because the absolute value is by itself. So x plus 4 equals 4. X plus 4 equals negative 4. All right, so subtract 4 from both sides. So x equals 0. Subtract 4 from both sides here. So x equals negative 8. All right, let's do one of these where we have the multiplication here. So how do I get rid of this 2 if I can't distribute it? Well, what this is saying is negative 2 times everything inside the absolute value, right? How do we get rid of things that are being multiplied? We divide them. So let's divide them. So divide both sides by negative 2. That cancels out, leaving me the absolute value of 3x minus 9 equals negative 3. Now we can split it. So 3x minus 9 equals negative 3. Wait a minute. Do you catch what I just caught? This equals a negative 3. Did I do something right or wrong here? I did something wrong. Do you see how I divided a negative 6? But then I'd forgotten I divided it by a positive 2. It should be divided by a negative 2. So negative 6 divided by negative 2 gives me positive 3. All right, check yourself. Watch out for these positives and negatives. All right, if it'll catch me, it'll catch any of you, and it catches me a lot, okay? So now that we've confirmed that this is a positive, because remember absolute value can't equal a negative, let's go ahead and continue splitting this. So 3x minus 9 equals 3, and 3x minus 9 equals negative 3. Go ahead and solve it. So we're going to add 9 to both sides here. So 3x equals 9, 10, 11, 12. Divide both sides by 3. So x equals 4. All right, let's go back and do the other half of this. Once again, we're going to add 9 to both sides. So 3x equals 6. Divide both sides by 3. So x equals 2. And the last 3 examples are just more of the same, so I'm not going to go over those with you. Excuse me. Excuse me. Final type of stuff here. The next type of absolute value equations we'll see involves equations with a variable on both sides of the equation. And these types, it is in these types that we sometimes encounter extraneous solutions. These are worthless answers because they don't work when we plug them back into the original equation. Not all problems will have extraneous solutions, just be aware that some may. What this means is anytime you're looking at an absolute value equation and you've got a variable on both sides of the equal sign, all right? Or you've got a variable both inside and outside of the absolute value bars, you have to check your answer at the end because it's possible that one of the answers you got will not work, all right? So let's do this one and this one, and we're going to do this very last one down here because I want to show you how to do that. All right, 2x plus 6 equals x. We have the absolute value isolated, so we can just go straight into splitting this and solving. So 2x plus 6 equals x. 2x plus 6 equals negative x. All right, I'm going to go ahead and move my x's first because I like to have them together. So I'm going to subtract x from both sides. 2x minus x is just x, plus 6 equals, do not leave this blank, x minus x is 0. Put a number here. Don't just leave it blank and leave me with x plus 6, okay? Subtract 6 from both sides. This gives me x equals negative 6. Going back up here to this one, and for this one, let's move the 6 first. So minus 6, this gives me 2x equals negative x minus 6. Move the x, so we're going to add x to both sides. So 3x equals negative 6. Divide both sides by 3. This is a 3. X equals negative 2. Now we have to plug these back in and check it. All right, and this is why I wanted the extra space. So let's check this one over here, the first one over here. So I'm going to plug in negative 6 into my original equation here. So absolute value of 2 times negative 6 plus 6 equals negative 6. Let me pick a different color just so we can see. Equals negative 6. All right. 2 times negative 6 is negative 12 plus 6 equals negative 6. Negative 12 plus 6 is negative 6. So far we look good. But then what is the value, absolute value of negative 6? It's just 6, right? Because it's talking about distance, so it can't be negative. So 6 equals negative 6. Wait a minute, that doesn't work. 6 does not equal negative 6. So this one is not a solution. All right, let's try our negative 2. Absolute value of 2 times negative 2 plus 6 equals negative 2. All right, 2 times negative 2 is negative 4 plus 6 equals negative 2. And then we're going to say negative 4 plus 6 is negative 2. Absolute value of negative 2 equals negative 2. Absolute value of negative 2 is just 2. So 2 equals negative 2. No, it doesn't. It does not equal negative 2. So this is not a solution either. So in this particular one, we do not have a solution. All right, we would do the same process for this one. And I'm not actually going to do that because we're out of space, but I do want to show you how to do this last one. What do you do when you have absolute value bars on both sides of the equation? It looks really stressful, but it's not. All you have to do is pick a side. Okay, so which side do you like best? Let's pick this one. All right, and we're going to call that our primary side, and we're going to split this accordingly. Okay, we're going to say 9 minus 2x equals, and one thing we just do plain, 10 plus 3x. Now the other side, we're going to say 9 minus 2x equals, and for this thing, for this side, we have to negate. We have to change the signs of everything on the right side. Okay, so right now I have a positive 10 plus 3x. So when I'm changing the signs, I'm going to say negative 10 minus 3x. All right, and that's how we do it. Just for repetition, just so you see, we would do the same thing over here. We'd say 4x minus 1 equals 2x plus 9. And then the other side, we would say 4x minus 1 equals, and change the signs of everything on this right side, negative 2x minus 9. All right, so let's go back to working out our example over here. We want x's all on the same side. So I'm going to say plus 2x here, plus 2x here. So 9 equals 10 plus 5x. Subtract 10 from both sides. So negative 1 equals 5x. Divide both sides by 5. So I get x is equal to negative 1/5. All right, let's do our other half. Once again, we want all of our x's together. I'm going to add 3x to both sides. That gives me 9 plus x, because negative 2x plus 3x leaves me x, equals negative 10. I'm going to subtract 9 from both sides. So I get x equals negative 19. And then we would take each of our solutions and we would plug it in up here, being careful to notice that this is absolute value on both sides when we plug it in. So make sure you pay attention to that. You're going to end up with signless numbers, positive numbers as your answers for both of them. Make sure that they work. All right, and that is all for today. As always, make sure you email me with any questions. Good luck with your homework. Have a great day.